Uh, well, I just have a comment on your email, Mark, which I think we are completely on board with that, in that we're interested in the phenomenology of stress in arbitrary systems, so down to bacteria, and uh, treating physiological stress as some internal measure of variational free energy. The comment I wanted to make is based on some physics work about what's the structure of an agent that can deploy multiple interaction modalities, so multiple ways of making measurements on the world and acting on the world. And Mike and I and Jim Glazebrook sort of foresaw this in our 2001 paper in Neuroscience of Consciousness, with the remark that interesting agents that had memory capability, et cetera, were going to be segmented into components that communicated classically. And Jim and I have now generalized that if you have a system that can deploy multiple reference frames that are distinct and so they don't commute, then those components of that agent have to be separable so they communicate classically. What that says is that the different components of a system are measuring different components of variational free energy, and that nothing is measuring the total variational free energy of the system, because there's no component that's looking at the entire boundary. Each component is looking at some piece of the boundary. And some of the boundary is devoted just to free energy exchange. So it doesn't get, that information flow doesn't get processed as information that one can do computing on. So if we want to model the system's best guess about its own VFE value, we need to have some metaprocessor that, instead of looking at the external boundary, is looking at the boundaries of the components that are looking at the external boundary and constructing a model of the VFE that those components are getting. So that's the beginnings, in a sense, of an affect system, right? That's what the brainstem in effect is doing, or what the midbrain is doing.
Well, that's basically almost exactly what I was going to say. So let me just say, first of all, I mean, this is the big issue that Mike brought to my attention. You know, it never occurred to me, to be honest, that basal cognition descends below the brain stem, let alone below the nervous system, let alone to the level of bacteria. So this has been the big eye-opener for me. I mean, among other things about Mike's work, and that was through Mike that I became familiar with it. I mean, it was before I met you, Chris. But that for me was the big eye-opener. Now, I want to just comment on, before going to the midbrain, I want to just comment on what you said to start with there, Chris, which is, I mean, maybe I'm just saying the obvious, but to me, it's such an important part of the obvious that it bears emphasis. Because the system has to measure how well or badly it's doing in relation to these multiple component needs. they have to be treated as categorical variables, which is basically what you've just said. And that the importance of that for me is that that becomes a sort of principled basis for qualia, because such variables, not being reducible to a common denominator, must be distinguished qualitatively. So that's terribly important, I think, for the whole business of consciousness, and starting with affective consciousness, because we're talking about needs, need gradients. So what is continuous? What is a continuous variable? Although I very much take your point that there's no component, at least at the level of the bacterium, and probably in any system that doesn't have this meta homeostat, which is in the midbrain, which is putatively in the midbrain. The common denominator is variational free energy, but there's nothing measuring it. So there's two possibilities. The one is, does anything have to measure global free energy? If each one of them is doing that, then the totality, the total workings of the multiple components still has the same outcome, namely that free energy in general is being computed. It's just being computed in compartments. But because each compartment has the same imperative to minimize its free energy, there is a global effect of minimizing free energy. So that's one way of doing it. The other way is the meta way, which we'll come to. But I want to just make clear that in my way of thinking, that common denominator is the valence. It just is bad for any self-organizing system for its free energy to be increasing, and vice versa. It just is good for it to be minimized, so for it to be reducing. So there you have value, tied, of course, to survival value, so tied to the basic value system of all living things. And that's the common feature of all affects, is they have a goodness and a badness to them. They have a valence. But there's an additional feature necessitated by the very point that we are discussing, namely that there are multiple survival gradients, that there has to be, in addition to valence, there has to be a specific quale, a specific quality. And I think it's terribly important that it is, at least as far as I can tell, it's obligatory that there must be a quality. The value has to have a quality, and there we're beginning to, as I said a moment ago, talk about conscious feelings, or at least conscious proto-feelings, or proto-conscious feelings, or something of that kind. So that's dramatically important. Now, to come to the other route, which is the meta homeostat. I think you have exactly in mind what I have in mind when you say that then we need to go to the midbrain, is that there is this terribly interesting fact that all of these homeostatic, all of these need monitoring systems send their residual error signal to the periaqueductal gray. The periaqueductal gray is, I mean, in those of us who've got such a thing, is therefore, I don't know if we can think of it as computing variational free energy in totality. It's just a matter, it appears, all that's necessary is a prioritization of those different homeostatic deviations. Which one of these, I mean, to the extent that there's an action bottleneck, where there's not an action bottleneck, where it's autonomic, it doesn't matter. But where some sort of action in the external world is demanded, then we start to come across action bottlenecks. So which one of these needs am I going to prioritize? Which one am I going to act upon first in the world? And it seems to me that that's the main thing that the PAG is doing, is it's prioritizing. And in the vertebrate PAG, immediately behind it, immediately dorsal to it, is the tectum with its superior colliculi, which is getting a condensed mapping of the multisensory mapping of the environment, what some people call a saliency map or an attentional map. And so between PAG and superior colliculi, the interaction between them, we have there the possibility of evaluating needs in relation to opportunities. The colliculi being the map of opportunities and the PAG being the monitor of needs. And that is a splendid idea, which is not my own. It was first formulated by Björn Merker, a Swedish affective neuroscientist, who's sort of retired now, I think, living in a forest somewhere. But that's my way of thinking about the issue that you've just raised.
Yeah. And how far down in phylogeny that kind of metaprocessing system goes that keeps this kind of multidimensional representation of stress updated is a good question. In something like E. coli, you might just have a bunch of stress components that nothing is trying to integrate.
Yes.
Mike probably has a better understanding of that from a physiological point of view than I do.
So I wonder, Chris, when you first started talking, you said down to bacteria. I was thinking, what about all the stuff below that? Specifically in the case of stress, issues of geometric frustration and materials, the kind of things people see in material science, right? And so on the one hand, you might think of that, magnetic domains trying to align and all that. You might think that that's what you just said, which is it's a bunch of stress with nothing integrating anything. And so that may be. But I also wonder, there's this notion which I see referenced from time to time, and I've had a really hard time finding anything any of the originals on it. But it's this, it's Wiener's notion of virtual governor. So it's this idea that in certain systems of multiple components where they're linked, and so the whole thing is rather unstable, and trying to control it by controlling each one is really hard. What he was saying is that you can define this global thing, and in his case, I think it was like a bunch of dynamos connected together, and they were super unstable that way. But what you can do is you can define this virtual, sort of super dynamo that doesn't actually exist. But what you can do is formulate a control strategy for that thing, and that works better than trying to manipulate the actual stuff that's there. And so, so now I wonder, in certain kinds of systems that may be not on the phylogenetic tree at all, that may be far simpler than that, if there isn't some sort of non-obvious virtual integration center that is doing some very primitive version of what you guys were just talking about, right? Trying to figure out which stress do I relieve first. So maybe this is a question for somebody like Robert Batterman, who studies this stuff at the mesoscale in materials, where you put some kind of material, and maybe a dumb material, or maybe it has to be some sort of one of these active matter things or what, but you put it under some kind of stress. And I wonder if there isn't a good lens that you can put on that, where you say, oh, look, here's this virtual thing that's actually deciding which buckles first, and who, which of the stresses do we relieve first? And you could even imagine a multimodal thing where there's physical pressure, but there's heat, there's magnetic domains. You could imagine a multi-sensory, so to speak, right, kind of thing. And so I don't know, maybe this goes further down, right? I don't know that anybody's done this, but I can sort of imagine defining such a thing.
Yeah, I mean, you can certainly think of something like the cytoskeleton as a
Yeah,
as
that's
a,
a good example.
elastic stress detector that has its own response capabilities built in, but also is signaling constantly to the rest of the cell
Yeah.
about elastic stress or mechanical stress.
Yeah, and I think wasn't it Gunther Buehler, I think, right, was the one who was saying that basically he was thinking that the microtubule organizing center was basically this sort of integration module for the cytoskeleton, trying to make decisions about what are the priorities and what is it, what's, you know, what are the morphological computations that the cell has to do next. Like he's got a lot of really prescient stuff in the I guess early 90s. I'm talking about the intelligence of cells implemented by the cytoskeletal network that's inside. So,
Interesting.
you know, so I don't know. I also wanted to ask Mark. I wanted to ask this special region of the brain that you're talking about that does this. But is there anything special about it aside from its connectivity? In other words, if you saw it in isolation from the rest of the brain, would you be able to say that, ooh, this is the kind of thing that would do that? Is there anything special about the neurons, or is it, or potentially could any collection of neurons do that if suitably connected to the rest of the brain? Anything special about it?
At the neuronal level, no, it doesn't have any special type of neuron. It's a rather poorly differentiated structure. It's in humans, it's well, in all vertebrates, as the name suggests, the periaqueductal gray, it is around the cerebral aqueduct of Sylvius, which is the canal, the central canal, which runs through the neuraxis, up the spinal cord, right up into the hemispheres. In the hemispheres, it's the lateral ventricles, and then there's the third ventricle between the two thalami, and then there's a fourth ventricle just in front of between the pons and the cerebellum, and it's between the third and the fourth ventricles. There's this little canal, and behind that canal is the tectum, which is, as the name suggests, the roof over the canal, and the periaqueductal gray wraps around the rest of the canal and terminates on the tectum. And it's 14 millimeters long in us humans, and it's got a columnar structure, which, as I say, is not very well differentiated, and the columns themselves are not that well differentiated from the surrounding white matter. The lack of differentiation partly speaks to its age. You know, it's an ancient structure, and its location around the canal, the central canal, is a precursor of what will happen higher up, at the floor of the third ventricle. The hypothalamus is there, and these there are several what are called circumventricular organs, and what that location bestows on them is the capacity to sample CSF. So they're sampling. There's blood flow through them. So they're sampling what's going on in the blood, they're sampling what's going on in the CSF, and then they're getting these neuronal messages from all of these various need detector, other distributed need detector mechanisms.
I mean, that's really interesting. This is the sort of thing I thought back a long time ago when I first heard about the so-called pleasure center, right? This kind of like this currency of reward. I thought, and so would you know that's what it was if it was sitting out in the dish somewhere? You know, is there something special about it, or it's anything could do it? It's just it has this like, functional connection with the rest of it. What does a pleasure center do all by itself, if anything?
Yeah, well, in the spirit of all three of our work, I would say, well, it all comes down to what kind of computations are being performed. It doesn't matter what the substratum is that's performing them.
Yeah.
But doubtlessly there's more to be said on the topic of the finer structure of the PAG that I wouldn't be able to speak to, because what I've told you is the limits of my own knowledge about its structure, but there may be more. I should look into it. But for the reason I've just said, I doubt that that's going to be the it's what sort of information it's processing and in what way it's processing that information. Now, at the level of E. coli, and I take your point, Mike, that why stop there? But let's pause there and let me ask, so these various components of stress that need to be monitored and acted upon, do the actions have to be prioritized, or can they be performed simultaneously? I'll tell you why I asked the question. It's because, well, actually, it's coupled to a second question. So let me ask the second question first, and then tell you why I asked both questions. The second question is the actions that it can perform in response to deviations from its preferred states. Are those actions monotonous? In other words, is there only a stereotyped response available to the organism? So why I ask both of those questions, remember I said earlier, which I say again, I think is a fundamentally important point, that if these are perforce categorical variables, that means they are in their very essence qualitatively distinguishable, must be qualitatively distinguishable from each other. And I said that is a principled basis for why qualia would come into existence. With a valence, remember, these are qualia about which the organism gives a damn. Existential value, they have. But if in addition to that, you have to prioritize them, then there has to be, so you could say each of these may be categorically distinct, but if they're being processed simultaneously and independently of each other, which they can be if there's no need to prioritize, then there's a less pressing need for them to be qualitatively distinctive in the sense of experienced qualities. Because if you're trying to juggle balls and you wanting which one you want to catch next, there needs to be some way of identifying it. So it would need to be, as it were, color-coded or flavored. Yeah. And the second reason implied in my second question is that you would then have to feel your way through the success or failure of your action. If the action is not just a monotonous reflex, but in fact, there's a trial and error component to it. Let me try this, let me try that. Is this working? Is that working? Again, sort of obliges us to assume that there's a palpating going on. And again, that starts to suggest something in the nature of, if you're palpating multiple systems, you need to distinguish them from each other, and there needs to be some particular way of representing how well or badly it's going categorically, which, they're even more than what I said earlier. I just don't see how it can be done without it being done by means of qualia of some kind. And to say again the obvious, why this is so important, is it is exactly that David Chalmers and his predecessors like Tom Nagel and others, they claim that there is no possibility of a mechanistic account of why there is something it is like to be the organism. they say a mechanistic account of something it is likeness, in other words, a subjective, qualitative, phenomenal experience, they say cannot be accounted for mechanistically. And I think that what we're talking about right here and now is a mechanistic account of how qualia come into existence. As long as you take the step, which I think is absolutely essential, I don't see how we can have a science of the mind without it, taking the step of contemplating the mechanism from the point of view of the organism. You know, you have to take the observational perspective of the organism.
Yeah. Well, I'll say at least two things about priority. One is all of these response modalities require energy. So the system has finite energy resources at any given moment, and a lot of stressors are stressors that decrease the energy supply. So a system in general is just not going to have the free energy available to deal with everything all at once. So that's one point to do with energetics. The other point is that a lot of these responses require gene expression. And so you have the question of how many, in something like a bacterium, how many operons can be transcribed simultaneously? And operons overlap in various ways. The polymerase for one is going to get in the way of the others and so on. So there's not just an energetic issue, there's also this structural issue that has to do with the way the genome is organized that will prevent the system from responding in every conceivable way at the same time. And, you know, I don't know the details of E. coli genomics in terms of where relevant stress response operons are. But for example, if your stressor is that you're running out of the sugar that you're currently equipped to process, then you need to express the genes for some other sugar. And if those operons are nearby, then you have to turn one thing off to turn something else on. And in, you know, mammalian or eukaryotic systems where the signaling pathways are so interwoven and cross-modulatory, then there are all kinds of winner-take-all or winner-take-most kinds of arrangements between signaling pathways, so which turn one off when another becomes active. So there's, and again, this may be an example of what Mike was describing in terms of a virtual governor, that it's just the way things are arranged enforce certain kinds of prioritization.
That's just fascinating. And what about the repertoire of responses? Are they fixed and immutable, or are there trial and error possibilities? In other words, the possibility of something that I would describe as voluntary action.
Well, at some outer limit, they're fixed by the genome. And you can't make proteins that you don't have genes for. But even there, you have the trial and error of gene transfer. You know, you can go out in the community and try to get new genes to do something that you need to do. Whether that's can be treated as voluntary or not, I don't know at the level of microbes, for example. But they certainly do it all the time.
I think that so two. I want to focus on two things. One is to just kind of broaden out. I mean, so I think if we think beyond bacteria, for example, I mean, right, you can't make proteins that you don't have genes for. but you can take actions in physiological and anatomical space that you don't have genes for. I mean, you don't have genes for anything, but in those spaces. But the point is, I think there's huge room for novelty in problem solving in those higher spaces, right? So maybe not in the protein space, that's true, but in these other spaces there is. And in particular, I'm thinking of a related model, and we're just starting a project now that I think will give a lot of data on these kinds of things, which has to do with our barium worm example. So what happens there is you throw barium on these planaria. Barium is a non-specific potassium channel blocker. So the cells are very unhappy, especially the cells in the head, because there's lots of neurons. They want to have potassium channel function. Their heads explode physically, just overnight they blow up. And then the next couple of weeks, these worms grow new heads that are completely barium insensitive. They don't care. And so we asked the very simple question several years ago: what's the difference transcriptionally between the barium adapted heads and the normal heads? And we found that there's a pretty small number of genes, only a couple dozen genes, that were differentially regulated in the light of this stressor. And of course, the best part is that planaria never see barium in the wild. So there's never been selection pressure to know what to do when you're hit with barium. So now that raises lots of interesting questions, because what it's doing is it's improvising a transcriptional solution to a physiological stressor that it's never seen before. So you can start to imagine what that might be like. And so is it generalizing from things that had seen before, which is maybe epileptic, hyperexcitability or something like that. But in any case, one of the things, what we're going to do is we're going to try to track cells, worms, and even groups of worms through this journey to find out how they explore that space, because it's like a 20,000 dimensional space of possible gene expressions. You don't have time for random search. And the worst part is that you can't just, you can do some experimentation, and maybe they do. So we're going to find out, do they like, is it a directed walk to the right region, or are they sort of ambling about and some of them find it? Do they all take the same walks? You can ask all this. But a lot of the changes you make are going to kill you long before you get anywhere good. You can't just randomly start, turning knobs on this thing. So that question of creative problem solving, generalization, navigation in this weird space where where you'd like to be, but I don't know if you know how to get there. I don't know if they have an internal coarse grain model of their own. That mapping between the transcriptome and the physiome. Which genes do I now regulate to have a particular physiological capability? Do they have a coarse-grained sort of manual to their own cell function somehow that they sort of know roughly what to do? Or is it a complete lightly directed search that they do? So I think all of these kind of notions of where do you go, what do you pay attention to, it's all going to play out there. So we'll see. We'll see how that works out. But another thing that I wanted to say, and I wonder if there's a name for this, and maybe you guys know what. And if there isn't a name for it, I think we should come up with a name for it, which is the flip side of qualia. So people who are interested in consciousness talk a lot about the qualia, but this emphasizes the receiving end, the inputs. Well, what does it feel like to be on the receiving end of various things that happen? But I'm really interested in the opposite side, which is the active end, which is what does it feel like to try to figure out what can I do next? What effectors do I have? What should I do next? It's the output. It's the output end, right? Which to me is really the critical part of the whole consciousness thing, which is, yes, what does it feel like to sort of be on the receiving end of being a sentient being in the physical world? But what is it? What's the flip side of that, which is I have to take action. And by the way, what do I have control over? So what do I know? What parts do I have? What are my effectors? Where is the boundary between me and the outside world? Do I really control, over there, or these are the effectors that I have? So that aspect of it, the active aspect, the fact that you can't, even if if you don't believe in free will or whatever, it's impossible to live that way, right? You can't. There's no way you could actually implement this. Well, I'm going to sit back and see what the Big Bang has ordained for me. I mean, there's no way to live, like, that's impossible for us. And so that aspect of it, the fact that no matter what, you have to be active all the time. So I don't know, is there a name for that, like the flip side of qualia?
Well, I would have to answer that question by disagreeing that the qualia are on the receptor or are particularly attached to the receptors as opposed to the effectors. I think the qualia are attached to the control center. And so the way that I would describe it is, and I'm using, I'm sort of bringing coals to Newcastle. I know that you guys are very familiar with these sorts of things, but the sensory states that are of interest are actively authored sensory states. In other words, I have acted on the world, given my model of the world, or my body, given my model of the world or my body. I have acted on it. And I expect, given that model, to now have this sensory consequence flowing from my action. And if the sensory consequence is what was expected, then all is hunky-dory. If it is not what was expected, then you have an error signal, and the summation of these error signals is what we need to minimize. The average error is what we need to minimize. Now, let's say within one of these homeostats that we're talking about, because there are these multiple homeostats, that is just the state of me. How it's not the state of the world, it's the state of my free energy. And you would probably actually have to say, given the point you've just made, Mike, about it being an action, and the way I've supplemented your point by saying it's an action with expected consequences, expected sensory consequences, then what the control center is monitoring is changes in expected free energy. So there we have, it's even more action-oriented when you start speaking about expected free energy as opposed to free energy. So this is in a way the point that I was making with Carl, by the way, yesterday made exactly the remark you just made, saying, well, consciousness is all about action. But it's in this discussion we had yesterday about illusionism versus realism, this very point came up. And I noticed that some of the people in the meeting, some of the colleagues on this panel, that they seemed to think what you've just said, what you initially said, which I'm disagreeing with, and I can see from your nods that you're not going to defend the view that qualia have to do with what the receptor samples, that seemed to be their view. That, and the whole idea of the illusion is this is what they were saying. The illusionists in the room. They were saying, well, so our qualia, what we're sampling, our sensory states are not the world. They are our sensory states. They're states of our blanket, and they are sampling just small components of reality. The ones that are of survival interest to me, and they're representing them in any old way that I like, and this is what that chap Donald Hoffman calls icons. It's just like Dennett speaks of a user interface.
Yeah.
And I mean, I accept all of that, except I don't think those are the qualia. I think that the qualia are my response to, in terms of what matters to me. That this active aspect again that you're speaking to, and that's an internal state. It's me measuring my free energy or my expected free energy. Are things turning out as expected, or is uncertainty prevailing from my current actions in relation to sensory parameters, which are not in and of themselves the point? Because remember, as we get increasing complexity, I don't mean of the predictive model so much as of the creature. the homeostats are no longer tied to in a one-to-one fashion to a particular sensory gradient, or a particular. I mean, like for example, an affect like fear, which is pretty basic. What sense is it? What sensory modality drives fear? Well, a whole lot of them. So it's what the homeostat is doing a pretty the control center is doing a pretty complicated job there. It's busy deciding, as it were, is this constellation of sensory inputs of error signals, is this constellation of error signals a fear constellation? And maybe fear is too complex an example. You could say pain. Likewise, it's not just one sensory gradient, and it's a whole lot of things. Mm-hmm. So
yeah, I mean, so
just to come, just to round off the point, since we've ended up talking about illusionism after all, my point to these colleagues yesterday was that means the quail is not an illusion. It is the direct registering of your own free energy. In other words, it's a measuring by the system of its internal state, its response, its subjective response to the actively authored sensory inputs or the deviations from the expected sensory inputs. And so that you can't call that an illusion. I mean, in what way can that be an illusion? It's not about some world beyond the blanket. It's about yourself. And sorry to have to say it, but I mean, what could be more obvious than that our qualitative conscious states are subjective states? They're states of us. They're not states of the world. But the illusionists don't disagree with that. But they, I think when it comes to affect, which they don't think about, when it comes to affect, which I think is the foundational form of consciousness, for all sorts of reasons, I believe that is the foundational form of consciousness. When consciousness emerged in nature, and through you guys, I'm learning it emerged a lot earlier than I ever thought. It would have taken the form of the kind of thing we're talking about now. It then becomes a whole different story once a organism is able to not only feel its own state, and remember why it has to, we've been discussing in the earlier part of our meeting today, all of those imperatives, why it must be a qualitatively differentiated subjective state of existential consequences. That is the subjective and the valence aspect of it. I've lost my train of thought. I don't remember what I was going to say about that. I think yes, that's what it was. So that once you have these, I feel like this, if I can put it into words, of course, such small organisms are not thinking in words, but I feel like this, it's just the raw feel. And then the additional adaptation becomes, I feel like this about that. And then we extend our affective fields onto a representation of the world, which must be, there must be some common currency, between the feeling and what it's about. And I think that's what perceptual consciousness then becomes. It's a sort of application of values onto the context which is generating, within which that feeling is generated. So that you can imagine all the functionality that flows from that. So now it's now you have the possibility of working memory, of saying, okay, I feel like this about that, so I must avoid that, and I must approach this. Is that right? Let me think my way through this. Okay, that's what's likely to happen. All those things then start to become possible.
I mean, I think you're 100% correct. I was just saying that I think, as you said too, a lot of other people focus on the input side of qualia. And one example of this that I think is interesting, and it's why I'm looking for a new terminology, is in all of these theories of consciousness, right? So we have epiphenomenalism. So the point of epiphenomenalism is that there is somebody home, so to speak, that feels things happen, but they have no causal power. They don't actually do anything. But what we don't have is the flip. Nobody, to my knowledge, nobody's proposed the flip kind of theory that, well, yes, there's action, but nobody actually feels what it's like, right? So people clearly prefer, they've sort of clearly emphasized the input side of things, but nobody's bothered to, and they've chopped it off from, I mean, obviously I think we could say incorrectly chopped it off from the other side, but nobody's chopped it off in the other direction that I know of. And so that says to me that going all the way back to when these things were first sort of proposed, there's this emphasis on the receiving end as opposed to the active end.
Well, it goes back to empiricism, to human lock.
Yeah, you're both pointing to the fact that this language was invented by people who viewed perception as a passive affair.
Yeah, exactly.
And had this idea of the observer that runs throughout classical physics, and the whole classical worldview, that the observer's not doing, and it doesn't have to do anything except just sit there and collect information. It's what the inactivists are rebelling against in their sort of confused language.
Yes, that's right. And that takes us, so it was Helmholtz was the whole thing of unconscious inference. That was the thing about the what is perceived is what is actively sampled. Carl always acknowledges that his whole way of thinking goes back to that early work of Helmholtz's, exactly on this issue of the active nature of perception, that perception is the consequence of an action. I had a slightly wild thought while I was listening to what you were saying, Mike. Not when you asked this question now about the flip side of quails and all of that, but when you were answering the question about the extent to which we may describe the action repertoire of, say, a bacterium. You talked about these worms that you study as including voluntary actions, and your answer is just extremely interesting. But as I was listening to that, I was thinking about the question that Chris started us off with in our conversation today, about is there anything that is orchestrating all of the different components? And the wild thought that suddenly occurred to me is, well, what's orchestrating it is the consciousness. That it's another, when you start thinking as we are in our conversation today, and every, you take this route and then you take that route and then you take that route, ostensibly discussing different issues, and they all just converge on the same answer. That it seems as if something like consciousness sort of more or less has to come into play if the system is going to be dealing with these sorts of problems. So it just occurred to me that basically what we're saying is what they nowadays call, I say nowadays, I mean, in relation to much higher, much more complex creatures, the so-called global workspace, and that's the whole idea. Is so that sort of suggests that overarching function is the global workspace, and the global workspace therefore is not an epiphenomenon. It's doing something, which wouldn't be possible if there was, you know, and I'm saying if that is what's doing the orchestrating, maybe that's the virtual regulator.
Mm-hmm. Yeah.
Good point.
Yeah. I mean, so I've got a student with whom we are running through the various popular theories of consciousness, you know, half a dozen or so, and just asking whether, for the same reasons that each of those theories associates consciousness with brains, we should then have to posit the same thing in the rest of the body and otherwise, because many of those things, you know, people talk about cytoskeleton and they talk about, you know, magnetic fields, and they talk about this kind of like action perception cycle and orchestration. I mean, these things go on in every part of the body all the time. And it's actually very tough to be able to, on any of these theories, to be able to say, well, clearly it's, you know, it's got to be the brain and it can't be this other. Like if as I think about it, if we can, and if we don't know very little about how it works, but you can imagine that with this trying to navigate your way through this physiological and transcriptional space with disastrous consequences if you go the wrong way, is it like something to be part of that process? Seems like it would have to be. It seems to me to be, it would have to be. And all of that at the same time as it's also like something to be that worm in whose body, right? That those are not the same. And so it seems to me perfectly plausible that there are multiple distinct consciousnesses associated with that system doing their various jobs in various spaces, you know?
Yeah, I was reading a paper just today that you wrote with somebody, Anna, what's her name in Lisbon?
Tunica, yeah.
Yeah. On, it was on nervous system, immune system interactions. But I can't resist making a further leap based on what you were saying, Chris, about the idea that the observer just sits there and observes. Of course, that point that you made there is is what leads us in physics into a participatory interpretation of, I mean, the whole of quantum mechanics, sort of the whole of the problem of the observer arises from. So it's not a problem that only psychology and neuroscience carried. It was the whole the passive observer of Newtonian physics gets problematized, and you can't leave the observer out of it all.
Yeah, well, I mean, looking back, what I think was really happening was the observer was being treated as a god, as not being a physical system at all. Because if you treat the observer as a physical system, then you're immediately faced with Newton's third law, which says interaction is interaction. and you have to be inactive. You have to be talking about the action side as well. So the only way to really have a passive observer is to have a supernatural observer.
Yes, God's eye point of view is what you're talking about. Yeah.
There's a really interesting project that I've got another student working on now. That's with a very simple. So I'll show you guys once the results are ready. I'll show you some of this. Very simple system, which are sorting algorithms. So, you know, you have a string of numbers, they're randomly distributed, and there's there's selection sort and then bubble sort, and these just, the whole algorithm is maybe 10 lines of code tops, right? It's just like these little, but of course, they also always presume two things. They presume an omniscient God's eye observer, which can see all of the pieces and moves them according to his plan, right? And it also assumes infallible hardware, that when you want two things to swap, they swap. And so we released both of those constraints, and we made versions of these algorithms that are cell's eye view algorithms that basically just talk about what does each cell want. Well, it wants to have neighbors that are in a particular order, but all the cells want that. And so when you do this, there's some amazingly interesting and bizarre capabilities of these algorithms that show up that are nowhere in the algorithm itself. If you look at it, I mean, they're completely not apparent from looking at the actual algorithm. They do some very interesting things, because then you can play all kinds of games. You can put different you can actually make different cells obey different algorithms, so they can be a chimera of two different sorting algorithms, and ask how the two interact, and so on, and how they navigate that problem space, right, of going from a jumble to a perfectly ordered. They all have a target of perfectly ordered. They do all this stuff, and you start to see all this, and this, I think this goes back to, what Chris was saying. You can't make proteins you don't have genes for, but apparently you can have functionality that you don't have algorithmic steps for, because and this is, the simple version of this is just sort of emergent to complexity or whatever, but I think it's more than that. I think there's more hiding in these things that you can gain access to that are in no way apparent from the examination of the details. So that, that observer thing is I think really interesting, moving it around, and also the evolutionary aspect, where